Okay, welcome back for part 2 of solving exponential equations. So again, remember if you're falling behind in your notes to pause the video and keep your notes up to date. And if you didn't quite get something the first time, listen to it a couple more times because sometimes it takes a few times for you to grasp the concept. Okay, let's jump right in. Again, this is 7.6 in your book if you want to keep reading and look at the examples. And we've already talked about the relevance, concept development, change of base, equality property. Let's jump to here. To solve exponential equations, we will first try to use the equality property. That was the first video. Today we're going to look at the second part. What if we can't do that? I can't rewrite my bases the same. It says, if this cannot be done, we will then use logarithms to solve. So we're going to use our logarithms now. So let's go ahead and jump right into our examples. So this is the example we worked in the first video, where we could rewrite the bases to the same. Here's the second one we worked, and again, we could rewrite the bases to the same. So let's take this one. All right, when it's not convenient to write each base or each side of an exponential equation using the same base, you can solve the equation by taking logarithms of each side, and that's what we're going to do. The best I can do with 4 is write that to a power of 2. 5, I cannot write to a power of 2. So, being as that's the first thing we look for, we're saying, hey, look, I can't do it, so what do we do now? Okay, so that's simply, we're going to take the logarithm of both sides. So, using logarithms, I'm going to go log base 4, because this is 4 to the x power. We want the base of the log to match the base of the, excuse me, we want the bases to match. And whatever I do to one side of the equation, I also have to do the other side. And again, this is log base 4 of 5. There we go. I'm taking the log of both sides. Now the common mistake is here is, okay, I want these bases to match. Well, on the other side, again, this is the mistake. A lot of kids want these two bases to match. No, whatever I do to one side, I have to do the same thing to the other. And remember what we're trying to do. We're trying to get the x down by himself. So when I make these bases to match, they're inverse operations. Log base 4 of 4 is going to equal x. This evaluates to simply x. Log base 4 of 5, I don't know what that is. Okay, so remember what we're trying to do. So whatever you do to one side, you have to do the other. And this base must match the base of where the exponent is. You need this x down out of the exponent. Okay, so this is, by the way, not a negative sign. I just grabbed my pen, so just for fun, let's just erase it so nobody gets confused. Okay, so I took the log of both sides, and now I'm left with this expression. I'm going to go ahead and bring it up here. So x is equal to log base 4 of 5. This does not help me. I don't know how to evaluate this. But using my change of base, I can now put this in a calculator. So using the change of base, I can say, now we have two choices. We can use common logs, LOGs, or we can use natural logs, LNs. Each one will give us the same answer in the calculator. I'm going to go common log. I'm going to go LOG. So this is my change of base. The 5 goes in the numerator, and the old base goes in the denominator. And using a calculator, I now can solve this. So let's go ahead and jot this down using change of base. And remember, the purpose of the change of base is simply so I can put it in the calculator. Okay, let's try one more. 9x is equal to 35. Now again, first step we always look for, can I rewrite these to the same base? Don't automatically jump to logarithms. This is 3 squared. 35, cannot write it to a bit power 3 or power 9. So again, logarithms of both sides. So this is going to be log of 9 to the x, and I'll come back for the base, log of 35. Now remember, here's my x. I want to get the x out of the exponent, so I have to get rid of the 9. So I want to make the base of the log match, well, this base, 9. When they match, I can or by, excuse me, I'm getting tongue-tied. When they match, they go away. They're inverse operations of each other. The x will come straight down, and whatever I do to one side, I have to do to the other. Okay, that goes to x because they're inverses. Now I have log base 9 of 35. Now to evaluate this, I'm going to use my change of base. I can say this is going to be, let's use ln's this time. ln over ln, so I'm using my change of base. And 35 will go on top. And the old base of 9 will go in the denominator. Okay, using a calculator, you now can find a decimal answer. All right, if you have any questions, go ahead and write them down on the side, and we'll try to handle them in class. Thank you.